Okay, welcome to your first notes on measurements. This is section 2 of Unit 1, Foundations of Chemistry. And we're going to talk about how different equipments have different precisions and what that means for the calculations that we make with them, and ultimately our meticulousness when we're comparing two measurements. We want to know how precise those measurements were. Okay, so what we say for precision, if the measurement has some precision, we're talking about, for example, here's our example over here. Ruler A is obviously less precise than ruler B. And so when we report a measurement with both of these, we keep track of what part of the numbers are real and what part of the numbers are not, okay? And those are called significant digits. So I'm going to zoom in here. Oops, I have to go to my hand. And I'm going to zoom in so I can write smaller. Put this up here. Okay. And I'm going to use that size. All right. So we call these significant digits. So which part of a measurement is significant and which part is not? Significant digits. So when we observe and record a measurement, we include in that measurement all the digits that are known for certain. Known for certain. And essentially that is what's marked on our ruler or our graduated cylinder or whatever, right? So if I go over here, for example, the digits that I know for certain are that the ruler A is greater than 300 and it's less than 400. So the hundreds place is the one I know for certain, right? I know that for certain because it's marked. In ruler B, I'm looking at the ruler and what's marked, and what I know for certain is that it's looks like somewhere between 320 to 330, right? So that ruler is more precise, and so I know for certain that it's somewhere between 2 and 3. So the tens place. The tens place is certain. And in this measurement, the hundreds place is the only one that is certain. Okay? But then, so if I'm looking at these measurements, I know for sure that in ruler A, even though it's only marked to the hundreds place, I know it's more than 300, right? And so that has value. That estimate where you're eyeballing the difference, what the measurement is, that has value. And so in addition to the ones that are marked for certain, we also include an additional digit, just one. So let's, I'm going to erase N. Okay, and I'm going to write 1. Only one. One additional digit that is what we eyeballed. And that's all you get. And one additional digit that is estimated, okay, or eyeballed, okay. So if I go back over to here again, here I can, so this student, right, in the example, the student recorded 320, so he eyeballed, and if you eyeballed that as something different, 330, that's fine. So there are differences depending on the person that measures, and people know that. So this student said it's 320. There's my pen. So 320. But the estimated digit, the only one, so this one is significant because we know it for certain. This one is also significant because he estimated that. This digit right here is not considered significant. It's just a placeholder. This one is not significant, okay? It's because it's 320. So we can't say that this is 323 centimeters, right? We can only say that it's about 320. And that's the limit of our precision. Okay? With this ruler, with the ruler B, if we call it 320 centimeters, right? We are estimating, and if I were to like zoom in here and try to draw a very precise line, I'm going to even get my ruler out here, which you can't see, but I'm going to get my ruler out, and I'm going to draw on here, let's see if I can, the 300, right? So, okay, even there. So I drew that measurement, and I'm going to call that now. I'm going to zoom back out. I'm going to call this measurement, instead of 320, I'm going to call it 322. Okay? So, and that's because this ones place now is the one that I'm estimating, and that has value. I know for sure that it's over 320 and less than 330. So this number is significant, okay? So if the student said it was 320, in this case, and it drops my purple, the 0 is significant. Because of the ruler was more precise, right? So in this case, the ones place is significant, where in this place it's not, okay? That's my bell. I'm going to pause this and come back to it in a little bit. Okay, so I think that's it on recording a measurement. So this is when you make your own measurements. You have to write always the digits of the measurement that you know for certain. Right, let's move back over here to the rules. All the digits that you know for certain. When you record a measurement, when you read a measurement, you write down all the digits you know for certain, and you add one that is your eyeball. Even if it's really small, you always are estimating between the two lines. Okay. When you're reading someone else's measurement, that's what we're going to talk about now, okay? You read someone else's measurement, there are some rules for which of those digits have meaning and which of them don't. And hopefully this will make sense as we go through it. Okay, so I'm going to make it bigger so that my writing is not too small. Okay, I'm going to go back to purple. All right, so there are 4 rules, okay, for determining how many significant digits there are in a measurement. So we're only talking about measurements. Okay, the first rule is that anything that is not a 0, so a non-zero number, non-zeros are always significant. I'm going to just abbreviate SIG for significant. Okay, so you read a number. Someone's not going to put a number in there that is not a 0 unless they mean it. So, for example, let's go back to our example here, right? 322, right? You're not going to put a 2 there if you only can estimate to the tens place. So, right? Like this one here. This is always 0 because the precision is, to the tens place. So we know it's somewhere between 300 and 400, and we're guessing that that's 320, which is the tens place. And so this is always 0, right? If we think that it's 322 instead of 320, we're going to write 322, and that's our estimate, and that's always significant. We don't write that number unless we mean it. Okay? So, any non-zero number you can assume is significant. Okay. Rule number 2. If the zeros between non-zero digits are, so I'm going to underline are significant. Okay? So if I have a measurement that is 302, right? This 0 is, of course, considered significant. If the ones place is significant, then the tens place is, of course, significant. So this, if I look at how many significant digits are in this number, this has 3 significant digits. The hundreds place, the tens place, and the ones place is significant. Okay, rule number 3. Zeros in front. This is where it gets interesting. Zeros in front of all non-zeros, okay, are not significant. All right, and I have to explain that. The reason that they're not significant is that, let's say we made a measurement and we measured something to be 2.5 meters, all right? And then we're going to do some math with it, and the math requires that we have that measurement in kilometers. Okay, so let's look at when we made our measurement. We were our ruler was marked to the ones place, and we estimated that it was halfway between 2 and 3, right? So we said it's 2.5 meters, and this one is our estimated number. So this has 2 significant digits. The eyeball is significant, so the half meter, that counts. So we said, okay, this is 2.5 meters. I'm going to do some measurement, though, and I need to have my distance in kilometers. So 2.5 meters is how many kilometers? Well, it's 0.0025 kilometers, okay? So the fact that I made that conversion does not mean that these zeros are now somehow significant, right? By the same token, if I had said, okay, now I need this measurement to be in millimeters. So, well, okay, so meters, I need to change it to 2,500 millimeters, right? That does not suddenly mean that now my precision is still to the ones place or to the tenths place. Like, that doesn't have any meaning. The significance is just to the 5, which is where we measured it, right? So that means that these zeros right here, these are not significant, okay? So this number has 2 significant, let me change this. This number here has 2 significant digits. This number here also only has 2 significant digits, okay? This one we're going to talk about in a second. This one here also only has 2 significant digits. These 2 don't count. And that's our last rule. So I'm going to write number 4 is that zeros at the end of all non-zeros, okay, the truth is they are sometimes significant and sometimes not, okay? So they are significant only if there is a decimal place, a decimal point is present. And that decimal point can be anywhere in the number, anywhere I'm going to scroll down here a little bit, in the number, okay? Okay, so here's some examples. If again, my 2500 has only 2. These are not significant. I'm going to underline the significant digits, okay? That has only 2 significant digits. These 2 are not significant for the same reason that it wasn't up here, right? Because it could be just a placeholder for a conversion. Let's see, what else could we do? If I wanted to okay, this is an important one. I'm going to move us back up here, way up here to our ruler, right? This student said that both of these numbers were 320, right? His estimate was not 322, it was 320. Here, this was significant to the ones place, here only to the tens place. So this 0 definitely not significant, this 0 is significant. How do you show that this one is and this one isn't. Okay, and I'm going to show you. We're going to go back. Oops. Oh, I just had the wrong thing. Scratch that all out. Okay, so the difference is 320, right? That has 2 significant digits. That's precise to the tens place. If I wanted it to be precise to the ones place, I'm going to put a decimal point. Okay. Now the 0 is at the end, and there is a decimal point in your number. Okay. Let's see. If there is a decimal point anywhere in the number. So what else did we say? Oh, right. 0's at the end. So let's say I made a measurement that was really precise. It was 32, well, let's say it's 320.0. Okay? I don't put this 0 in here unless I absolutely meant that I was precise to the tenths place, right? So those zeros, here's my decimal point, right? So this 0 is significant. So this number has 1, 2, 3, 4 significant digits. It is precise to the tenths place. Okay? This number has 3 significant digits. It's precise to the ones place. This number right here only has 2 significant digits. It is precise only to the tenths place. So they had a ruler that was, this is the ruler that was measured to the hundreds place, right? So we have to think about that. When you have really small measurements, okay, let's see, or let's say I had, yeah, zeros at the end are significant if there's a decimal point. Does that make sense? So, right, this one is significant, there's the decimal point. This one is significant, this one is significant because there's my decimal point. I could add a ton of zeros at the end here if I was really had some really precise measurement. Those would all be significant, okay? This one only has 2. These zeros are not significant because there's no decimal point. These are, this one is not, right? It's the decimal point. Now I want you to remember to compare that to, let's go to the hand here again. This one, zeros in front, these are never significant. Zeros in front are never significant. So maybe we should write never, not, never. They're never significant. Even if there's a decimal point, here, right? So here's my decimal point, 0.0025. Zeros in the front are never significant. Okay. We need to make a qualification here about, so I'm going to go down to measured versus defined quantities. Okay. The qualification is that measured, we're only talking about measurements. Okay. Measurements have precision. They have significant digits. You have to keep track of what's significant and what's not significant digits. Okay. Defined or exact quantities are considered, these are considered conversion factors. They can be conversion factors. You can convert, these are not included in the idea of significant digits, okay? So they're not included in counting how many significant digits. How many significant digits, okay? So anything that is a precise, trying to think of, like if you look at, let me think. Oh, conversion factors, like there are 100 centimeters are the same as 1 meter, right? It does not matter that there's no decimal point here. Okay, this is a precise, exact quantity. And so if we're talking about a conversion here, if we want to convert meters to centimeters and we're going to use these numbers, those are considered perfect. So we don't include them in counting our significant digits. only measurements. We're only talking about measurements. This is where we use them. Okay, it's been 20 minutes. I got one more thing to show you, and that is about scientific notation. So I'm going to come over here to, so here's some, I didn't notice this. Here are examples, again, of that idea of exact quantities, right? 1 dozen eggs is always exactly 12 eggs, and that has no relevance. It's not a measurement, so we don't include it in determining the number of significant digits. That'll make more sense when we do operations with measured quantities. We're going to like add and divide and stuff. So I'm going to go to the hand. I'm going to come down. I want to see. Okay, so here's our example here. We're going to look at this. Which digits are significant? That's a good example, so I'm going to blow it up, and we'll look at that. Okay, so just for a quick practice, let's recall here. I'm going to underline the significant digits in this number, okay? Rule number 3 says the zeros in front are never significant. So there's these first 3 zeros right here. These do not count in determining the significance of the number, okay? All of the non-zero digits are significant, right? All of the rule number 2 says zeros between are significant, okay? And the last rule, rule number 4, said the zeros at the end are significant if there's a decimal point anywhere in your number. So this is at the end, right? And so then I look for a decimal point. Here's my decimal point way over here, okay? So that is significant, so that one counts too. So this one has 1, 2, 3, 4, 5 significant digits, okay? So how many digits are significant? The answer is 5, all right? Okay, so then the question is, because we use so many really big numbers and really small numbers, we have a lot of zeros going on. Even like this number has a lot of zeros here. We don't like to use zeros. We want to get rid of the zeros, and so we use scientific notation to write numbers without all of the zeros, all right? And so the general form of a scientific notation number, and I don't know if this is a review or not for you, but I kind of hope it is this thing right here. So M, we're going to call it M. This is just to represent, this is an integer, which means it's a whole number. No, it doesn't have to be. It's an integer. It's a number, it's a number between 1 and 10. The integer is just, it's the big number. Let's say that. The integer is what we call the big number. All right, and it has to be between 1 and less than 10. So between 1 and 10. It can be 1 and it can be 9.99999, right? Okay, then we take it times, and if we've removed all the zeros, then we're basically taking out tens. So times 10 to the power of an exponent. So n in this case is an exponent. This is what we call an exponent. And it's basically how many tens. Okay, so it must be a whole number. It's how many tens did you take out? It must be a whole number. Okay, so as an example, this number right here, okay, we need to, when we write this number in scientific notation, we need to rewrite it. So we need to take out zeros so that the number is between 1 and 10, okay? And that's going to make it 1.2050. Okay, remember that these zeros were not significant anyway. These numbers were all significant, and so I have to include them all. And then how many zeros did I take out? So times 10 to the power of. Now this is a really small number, so I actually had to add zeros, which I had to add tens in order to change that number from this was the 1,000th place to the ones place. Okay, So I moved my decimal place 1, 2, 3 places to the right. I took a really small number, and it was 3 tens, so I added 3 tens, okay? So what I'm really doing here, since I added 3 tens here, I'm taking away 3 tens over here. So this is 10 to the minus 3. So for small numbers, so we're going to write small numbers, and that's less than 1, okay, have negative exponents, okay? And so let's do one more example here since we have a little space. I'm going to give you one more example. The number we're going to do, let's just make up one, 553 million. Okay, let's add 9 zeros there. That's a huge number. We hate doing math. I would hate to do math with all those zeros. So this, I'm going to put it in scientific notation so I don't have those numbers. Again, I want to find a number between 1 and 10. So that's going to put it right there. So that number is going to be 5.53. Okay? Zeros at the end of a number only count if there's a decimal point. So none of these zeros here count. These are all going to go away. Okay? I don't have to include them here. They are not part of my precision. They're not considered significant. They're just placeholders. This was measured to the 10 millionth place, and it was estimated to the 1 millionth place. Okay, so then I'm going to take out the tens. I'm taking out tens, and how many tens did I take out? I took out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I moved my decimal place 11 places to the left, so I took out 11. I took out 11 tens, and so it's times 10 to the 11. Okay, I hope that makes sense. That's it. It was a little bit long. I got 27 minutes. We will practice this Monday. Tomorrow, Friday, we're going to do our baggy lab. So that's it for the notes, and I'll see you in the morning. Bye.